All right, today what we're going to find would be the missing sides of our vector diagrams. Now, what we're going to operate off of is the idea that you are under the understanding that we have the angle of a vector diagram given to us, and that you're able to label the sides relative to that angle. So if this is my starting point right here, and we're going to imagine that this person is going to walk 10 miles relative to our starting point, but the path that they take is going to be to the southwest. So they're going to walk 10 miles, let's say, to the southwest. Some component of that, if it's to the southwest, we know that some part of it is to the south. That's what this part right here would be. And some part of that motion would be towards the west. That's why we say it's to the southwest. All right, so just keep that in mind, that we're actually looking at, say, some cardinal directions, and the resultant vector is the combination of us moving toward the south and toward the west at the same time, and that's what gives us this resultant vector right here. Okay, so from the perspective of the 28-degree angle, the x is going to be labeled as the opposite side, and then the 10, that's going to be labeled as our hypotenuse. Okay. If we want to find out how far south this person would have walked relative to where they started, now notice I said toward the south from where they started, not the total distance that they walked. They walked 10 miles, but we're trying to figure out how far south they are from their starting point. In order to do that, we need to use some trigonomic functions. These things right here, SOHCAHTOA. Okay. From those circle diagrams, we need to identify, are we going to find the answer using sine, cosine, or tangent? This is the part that people have problems with. And it's really not going to be that difficult if you labeled your sides. See, if you labeled the sides, you have O and H, opposite hypotenuse. Well, down at the bottom, the first one over here on the right-hand side, tangent, has opposite adjacent. That doesn't match. So that can't be the one I need to use. Cosine has adjacent hypotenuse. Those two letters don't match. If I come over here to sine, sine has opposite hypotenuse. I have opposite hypotenuse. That's the one I need to use to solve this problem. So I'm trying to find the opposite side. So what I'm going to do is I'm going to cover that up in the diagram. And that means that I'm going to take sine theta times the hypotenuse. We're going to show the work for everything that we do. We have sine 28 degrees times 10 equals. Now in your calculators, first thing you always have to do is make sure that your calculator is in degrees. Okay? So it should say DEG at the bottom right of your calculator. That's what you got to put in. A reminder, second reminder, that working with your calculator, that sine 28, what does that actually mean? Sine 28 is going to give you a trigonomic value of 0.4695. Let's round it off there. We are going to take that value, the 0.4695, and we're going to multiply it by 10. Now, if we did that like this, you'd end up with a, by 10, not 100. Look, I figured it looked kind of funny there. Okay, that's why we're going to punch it into the calculator to make sure that we're right. So it should be 4.695 is what it should be. Okay, so we're going to double check this. That's what it should end up as. So if we type in sine 28 times 10, you're going to notice something wrong. comes up with a negative 0.98. Well, the issue that we have here is we didn't close the parentheses after the 28. See, sine 28, the trigonomic value, the decimal that's associated with that specific angle, is 0.4695. When we forget to close that parentheses, what the calculator is looking at right now is not sine 28 times 10. It's looking for sine of angle 280. You've got to close that parentheses. So we're going to go sine 28, close that parentheses, times 10, and sure enough, we end up with the exact same answer. That's what it should be. Okay? All right, we're going to do two more. We're going to do one of each type of trigonomic functions, and then you're going to do the rest of the page on your own. We're going to hop down here to letter F. Letter F, we first begin by labeling the diagram. So my vector angle is going to be 12 degrees. That's where my starting point is going to be. Okay. And this resultant vector is going to be pointing, in this case, to the northwest. But we don't know how far northwest, let's say, the displacement's going to be. How far did the person walk to the northwest? We don't know that. Now, what we do know from this is we do know that the person walked from the starting point. They're going to end up 9, let's say, miles. They're going to end up 9 miles west of where they started, but as they were walking towards the west, they were also walking north, and they ended up going along this path right here. Okay. In order to solve this, we have to label our sides of our triangle, our vector diagram. So from 12 degrees, the hypotenuse is always going to be the longest side. And then the north component over here, that's going to be labeled as the opposite. So that leaves the last side of our vector diagram as our adjacent side. Okay, we need to identify what trigonomic function we're going to need to solve this particular problem. So I look at my list, circle diagrams. Which one do I use? Well, that's as easy as labeling what you have. The opposite side, I don't have any information on that at all. It's not asking me to solve it, so I'm not going to look at the O whatsoever. But I do have to solve for the X. That's the hypotenuse, so I'm going to think about H. And then I know the adjacent side has a 9 to it, so I'm looking for the trigonomic function that has A and H. Down at the bottom, tangent has O and A. I don't have an O and A. I have A and H. I have the adjacent and hypotenuse, so that can't be it. I go to my next one. I have adjacent. I have hypotenuse. Those two things, well, I've got the A and I have the H. That matches up. So that's the one I have to use. Now I'm trying to find the hypotenuse. So if I'm trying to find the hypotenuse, I'm going to cover this thing up. And what am I left with? I have the adjacent side divided by cosine. So I'm going to show my work. I put down the adjacent side, which is 9, divided by cosine of 12 degrees. And then in my calculator, we'll punch that information in. So again, just making sure that your calculator is in degrees. We'll start off by putting in 9 divided by cosine 12. We hit enter, and you've got your 9.2. Now typically, I don't care where we round off at, but you have to be at least aware that the hypotenuse, if it's the longest side, you can't round that thing off to be 9 because it'd be the same side or same length as the adjacent side. So when you are looking at these, I don't care where you round off unless the hypotenuse rounds off to be the same value as one of your other sides. That cannot happen. Okay. We're going to do one more triangle, one more vector diagram. And let's pick, look at my list. Let's do J here. So J, last one we're going to do, and then I'm going to turn you loose. J, our angle is down here in the bottom right. That's a 68-degree angle, so we think of this as our starting point right here. The path that you're going to follow here is always going to be the longest side. That's going to be the hypotenuse. And if I'm operating off of the understanding that my starting point, I take a 68-degree angle from there, and if I'm standing at that starting point, that means that the opposite side to where I'm starting from, I'm looking out of that angle across the 1.5, and we could think of that as north because it's straight up and down. The 1.5 is pointing up. It's on the opposite side of the 68 degrees, so that's the one that's going to be labeled as your opposite. The X then ends up being your adjacent side. So always start by labeling the hypotenuse, looking at your angle, identifying the opposite side, and then the leftover is going to be your adjacent. All right, we have to figure out which trigonomic function we're going to have to use for this. So I look at my list. From the letters that you have written down, we have opposite, O, adjacent, A. Yes, we have the H labeled here as well, but we're not asked to solve for that side. We don't have any numbers there, so it's just labeled. We're not looking at it. So you have the O and the A. We look at our functions. Sine is O and H, so that can't be right because we have O and A, not O and H. We have cosine is adjacent hypotenuse. We don't have adjacent and hypotenuse. We have opposite and adjacent, so that can't work. So you go over here, you have tangent, opposite, adjacent. That's the winner. Okay. I'm trying to find the adjacent side. So I'm going to come down here. I'm going to cover up the adjacent. So that means that I have opposite divided by tangent theta. Show my work. I'm going to have the opposite side is 1.5. We could think of this again as miles that we would have walked toward the north. Divided by, we have divided by tangent 68 degrees equals, and now going off of our last problem, we're trying to find the adjacent side now. Okay, just looking at the size of our sides of our vector diagram here, we're going to have to end up with something less than 1.5. So if you end up with something that's going to be larger than that, I mean, just look at the picture. The picture, you have two different sides of this vector diagram that are distinctly different sizes. So if it's a smaller side of our vector diagram, then we have to have a smaller value associated with it. So we'll put this value into the calculator. We're going to have 1.5 divided by tangent 68, hit enter. Sure enough, we end up with something smaller. So this would be 0.6 rounded off, and you've got your answer done. Now, I know the one thing that some of you might say, well, why in some cases do we divide? Well, it goes to the circle diagram. We divide because we were trying to find, in this case, the hypotenuse. But in the first diagram right here, why did we have to multiply? Why did we have to multiply? Because we were trying to find the opposite side, and it all is what's being covered up in our circle diagram. All right, so for the rest of the period, what I want you working on is answering the rest of this page right here, the A through Q, and you're going to show all of your work in terms of setting up your sides. So It shouldn't take you too long. If this is my angle, that's my opposite side. This is my adjacent. This is the hypotenuse. Operating off of that idea, you have opposite and adjacent sides. So that means that you're going to be using the tangent. Tangent, we're finding the adjacent side, so I cover up the adjacent side. So you'd have 12 divided by tangent 24, and you work it out. So it can be done that quickly. But it can only be done that quickly if you have taken the initiative to writing down these 3 circle diagrams. And I'm going to make them nice and large here, and I'm going to leave it on the board for you to work with. But you have that page to finish up. That's what to do tomorrow. Okay?